Hi there and welcome back to the Good Tutor Premier Prep SAT course, and in this video we're going to continue our look at the problem solving and data analysis subsection of the SAT math section, and specifically we're going to take a look at statistics, sampling, and bias. Alright, so statistics are really what help us interpret and apply numerical data. They help us make sense of numbers and give it some context within whatever situation we're talking about it. So on the SAT, we're concerned with 6 main statistical values, and those are mean, median, mode, range, standard deviation, and margin of error. Let's go ahead and take a look at each one of those. So mean is the sum of the values divided by the number of values. So we add all of our values up in a given data set, and then we divide by the number of values that we have. It's also known as the average. So if we have the data set 1, 2, 3, 3, and 6, in this case, we would add those up, which would get us 1 plus 2 is 3, plus 3 more is 6, 3 more is 9, and 6 more is 15, divided by the number of values that there are, which is 1, 2, 3, 4, 5. So 15 divided by 5 would be 3 for our mean, or our average. All right, the next one is the median. The median is the value that is in the middle of a set when the values are arranged in ascending order. And again, this is smallest to largest. So if we have that same data set 1, 2, 3, 3, and 6 in ascending order, the median would be the middle value. And we find that middle value, especially for bigger data sets, right? We're going to go like this, and mark off on each side until we get to that middle value. And in this case, our median will also be 3. The mode is the value that occurs most frequently in a data set. So I have their mode equals most, right? That's always the way I remembered it as a student. So again, if we have that same data set, 1, 2, 3, 3, and 6, we see which number occurs most frequently. You guessed it, 3. So 3 is also our mode in this case. The range is the difference between the highest and lowest value in a data set. So the formula for range is that range equals the largest number subtracted the smallest number. So largest minus the smallest. In our same data set, 1, 2, 3, 3, 6, that would be 6 minus 1. So our range would be 5. Then next is standard deviation. And standard deviation is how far a typical data point is from the mean. A low standard deviation means that values are more concentrated near the mean. So if we saw a graph of that, and this was the entire graph, it would look something probably more like this, with pretty concentrated values, right? A high standard deviation, on the other hand, has values that are more spread out from the mean. So if we were to see that graph, it would probably look something more like this, right? So you have to understand standard deviation, what it says about a data set and what it looks like on a graph, right? But you do not need to calculate it on the SAT. So it's just important to know what a graph will look like depending on low and high standard deviations. Margin of error is similar in that margin of error is the maximum expected difference between a true statistics measure for a data pool and the same statistics measure for a larger sample from the data pool or the entire population, right? So in this case, the key with margin of error, because you don't have to calculate it either, is to know that a larger sample size has a lower margin of error. Meaning the larger we have of a sample size, the more representative of a population it is in most cases, right? So if we have a city of 100,000 people and we ask 10,000 people instead of just 500, well, that sample that had 10,000 people is probably going to be a better representation of everyone in the city than just 500 people, of course, assuming all else is equal, and we went through the same methods of picking people. All right, so to introduce you to the ideas of sampling and bias, there's populations and samples. You heard me mention those in the last slide, right? So a sample is the small group that we take out of a larger population. So again, in that example I just said, right, the population would be the city of 100,000. The sample would be whatever group of people, whether it's the 500 or the 10,000 or any other smaller group that we take out of the entire population. And the goal is to have a sample that is representative of a population, meaning the statistics that come from that sample are pretty similar to those that come from the population, because if we've done things right and we've picked people the correct way and things like that, then our sample should be a pretty good representation of the entire population. Two things, as I mentioned briefly there, that make for a good representative sample is 1, a large enough sample size, and then 2, making sure that they were randomly selected, because if they aren't, we'll run into the next point, which is bias. And bias are factors that may affect the reliability of a sample. And on the SAT, we're concerned with three main kinds of bias: convenience bias, exclusionary bias, and sample size bias. And we'll see an example of that in a second. So convenience bias says that basically we just went to the people that were right in front of us, the people that were easiest, and in doing so, we may have left people out. So if you needed to perform a survey to get an opinion of students, let's say, throughout your school, but you only asked the people that sit at your table in first period, well then that was convenience bias, right? You just asked the people you were going to see anyway, as opposed to actually going out and trying to find other students from around the school to get opinions of. Next is exclusionary bias. As its name implies, exclusionary bias says that we're leaving someone out. So let's say you had a survey you wanted to run to ask people in a city what their opinions were on bees. But in your sample, you only asked people from the city who were allergic to bees. Well, that's pretty exclusionary, right? You left out all the people who aren't allergic to bees. And in doing so, you create this bias that because most people who are allergic to bees probably aren't going to think too highly of bees, right? So you've left out an entire group of people. Last is sample size bias. And this just means that if we have too small of a sample size, it's not likely that that sample is going to represent the population. So in most cases, a larger sample size is going to be better for being more representative of a population. All right, so if we view an example here, this example says that a school wants to determine the average number of books read each year by its students, so it conducted a survey of 100 students in the school library. The average number of books read per year by these 100 students was 51.5. Which of the following statements must be true based on this information? A, the survey is biased due to a poor choice of sample method. B, the survey is not biased and will likely produce a correct estimate of the number of books read annually by students. C, the average number of books read annually by all students is 51.5. And D, the average number of books per student per year cannot be determined from such a small sample. All right, let's see each of these. So if we start there in the last one we read, that the average number of books read per student per year cannot be determined from such a small sample. Well, out of a school, 100 students isn't really that small of a sample. It's not a bad sample size considering your population, right, is only maybe a couple thousand students. So that's not a terrible sample size. So it's probably not that one. The average number of books read annually by all students is 51.5, meaning the average for the entire school, basically, all the students combined only read 51.5 books. Probably not, right? They probably read a lot more than that, considering the books per year per student for those 100 students was 51.5, so probably not. The survey is not biased and will likely produce a correct estimate of the number of books read annually by students. And here's where we get down to A and B, probably not B, right? It's not B, because this one is going to be a little bit biased. And we ask ourselves, why? Well, they're asking about students reading books, and they only ask students who are in the library. That is one sort of convenience bias, right? Because it's easy, of course, to ask students that are in the library about reading books. But it's definitely exclusionary bias because you're leaving out those students who don't spend much time in the library, right? So they're likely going to bring that average down, right, if they're not spending as much time in the library. Because students who spend more time in the library are probably more likely to read more books, right? So this one would be A, because the survey is biased due to a poor choice of sample method. They should have asked students from all around the campus, from the cafeteria maybe, right, where all students have to go, as opposed to the school library where a very small population or a relatively small population or sample will go out of the entire school population. All right, that is it for this video. In our next video will be an introduction to probability.